Hi everyone, welcome back. We'll be looking at how to calculate the mean rate of reaction. You'll need the following equipment as we go through this lesson: a pen, pencil, paper, graph sheet, ruler, and rubber. By the end of this lesson, you should be able to calculate the mean rate of a reaction using data for reactants and products. You should be able to create rate of reaction graphs and interpret them. And finally, you should be able to construct tangents to the curves on rate of reaction graphs. We'll begin by looking at calculating mean rate of reaction using data provided for the reactant or product. The rate of a chemical reaction can be found by measuring the quantity of a reactant used or the quantity of product formed over time. Now, in terms of reactant use, we can calculate the mean rate of reaction by dividing the quantity of reactant used over time taken using this equation. Or, in terms of products, we can calculate the mean rate of reaction by dividing the quantity of the product formed by time taken. Pause the video, write these equations down, and then we'll try to do an exam question. Right, here's the exam question. A student investigated the effect of the size of marble chips on the rate of the reaction between marble chips and hydrochloric acid. The reaction produces 1.6 grams of gas in 30 seconds. Calculate the mean rate of the reaction in the first 30 seconds. Think about which of your two equations you would use to calculate the mean rate of reaction in this question. If you stated that you use the one for products, then you're correct. Because we're focusing on the amount of gas produced, then the mean rate of reaction would calculate it by dividing the mass of product produced by time. Now have a go at doing this calculation. Pause the video and try it out. Now in this question, the mass of gas produced is 1.6 and the time taken is 30 seconds. To calculate the mean rate of reaction, we'll divide 1.6 by 30 seconds. Your final answer, you can round it off to 3 decimal place. It is 0.053, and the unit that you need to focus on, it is grams per second. Now with units, for rate of reaction, the units, it might be given as grams per second or centimeter cube per second, or also as mole per second. We can also calculate the mean rate of reaction using data from a graph. Let's look at this exam question. It says calculate the mean rate of reaction for the first 2 days. Now looking at the shape of this graph, we can see that it is based on reactants, because as a reaction is going on, the mass of reactants would be decreasing. Now, to calculate the mean rate of reaction using the data from this graph, the first thing that we would need to do is draw a line coming up from day 2 to meet the curve. Next, we would draw a line going across to the y-axis to find out where the mass finished. And just as before, we'd use our equation, which would be the quantity of the reactant used divided by time. In this case, it is 40 divided by 2. So your rate of reaction would be equal to 20. And if you notice the unit in this case, it is grams per day. Now think about this question. If we doubled the mass of the reactants, what would happen to time? Pause the video, think about it. Now, if the mass of the reactants were doubled, instead of being at 40, we'd be at 80. Now, going down, notice what the time would be. It would take less than 2 days. So that simply means that the reaction would be going at a faster pace. It's because with the mass being doubled, the concentration is higher, so you have more particles available for collision, for effective collision for this reaction to go at a faster pace. You should also be able to create rate of reaction graphs. Here's a follow-up question to the one that we were looking at earlier. The table below shows the students' results from the same investigation. Plot the data from the table and draw a line of best fit. Now get your graph sheet, get your pencil, and have a go at plotting your graph. Now, in plotting your graph, you need to draw a horizontal line going across at the bottom to represent your x-axis, and try to find a suitable scale. As you can see, I've got my scale at the bottom. For every 10 seconds, I'm using 2 centimeters. Now, for my y-axis, the mass of gas produced in grams, for every 0.5 mass of gas produced, I'm using also 2 centimeters. Let's move on to plotting our points. Now, look at your table, the data in your table. Try to find the data for the x-axis, which is time in seconds, and the y-axis, which is mass. So for the first point, it would be 0 and 0. So your first point would go there. Then follow that up with time 10 and 0.8 for the mass. So that point is there. And then you just follow through with the rest of data. So I've got mine for 20 seconds, that is 0.6, 30 seconds, 1.6, 40 seconds, 1.8, 50, and 60, I've got 2. Next, you need to draw a line of best fit. In this case, it is a smooth curve. Okay, here's a similar graph to the one we plotted. This is a different exam question. In this case, it says, a student investigated the effect of the size of marble chips on the rate of the reaction between marble chips and hydrochloric acid. The graph shows the student's result. Now on this graph, we can see our time in seconds on our x-axis and our volume of the gas produced in centimeter cube on the y-axis. Now, the first question says to describe the trend and use values in your answer. Second question says describe how you would use the graph to find the rate of the reaction at 15 seconds. Our first question, it says describe the trend, use values in your answer. Pause the video and have a go at doing this. Now, in describing the trend, we must include a time or volume value. In this case, the volume of gas, it increases from 0 centimeter cube to 60 centimeter cube in 30 seconds. Now, the next thing that we should do is include time interval or volume increments. The volume increases less rapidly between 10 seconds to 30 seconds, or between 0 centimeter cube to 60 centimeter cube. We need to also state the time or the volume when the graph line levels off. The graph, it levels off at 60 centimeter cube or at 28 or 30 seconds. The values, they must be approximately correct. So observe your graph carefully and ensure that you're using the correct values. Now, in order to do the second question, it says describe how you would use the graph to find the rate of reaction at 15 seconds. Firstly, you'd have to draw a tangent at 15 seconds. We'll look at this later on. Next, you should calculate the gradient. So you would draw a straight line on the curve at 15 seconds, then calculate the gradient. To draw tangents for rates at specific points, it is similar to what you would do in maths. In maths, a tangent is a line that touches a curve but does not cross it. Now, looking at our graph, where should we put the tangent to find the rate at a specific point on the graph? Pause the video, think about it. Right, to draw a tangent that touches the curve at 15 seconds. Remember, we're trying to find the rate of reaction at 15 seconds. So you would draw your tangent as shown with this blue line. It's a straight line touching the curve at 15 seconds. Now, connect the ends of the tangent to form a triangle. Going across, then going up. Now, this information can now be used to calculate the gradient as we discussed at the start of this video. And then that would be our mean rate of reaction.